In the previous lesson, we saw a simple example of a recursive function, sum digits r. And this function is able to calculate the sum of digits of any integer n. We have here a recursive call, sum digits r, and a conditional if. And together, they act like a loop. They repeat a calculation until some condition is satisfied, n is equal to 0. So each execution of the function body corresponds to one iteration of the loop. In this lesson, we will go to the root of this intuition. We will understand in a deep way the connection between recursion and loops, and we will see how to write correct and efficient programs that use recursion. We will see that a recursive function is exactly the same as a while loop if one essential condition is satisfied, if the recursive call is the last operation done by the function. This is called tail recursion. We will give a technique called invariant programming to program these correct and efficient loops. And this technique will apply both to the functional paradigm and the imperative paradigm. It's not limited just to functional programs. Tail recursive functions and while loops, which correspond to each other. But in this lesson, we will only look at the functional paradigm. By the way, an imperative paradigm is a programming paradigm in which variables can be assigned more than once, multiple assignment of variables. Many languages, such as Java and C++, allow this, but the functional paradigm does not. So as part of the technique of invariant programming, we will define two formal concepts. One, the specification of a function. This is a mathematical formula that defines exactly what the function calculates. And second, the invariant of a recursive function. This is a mathematical formula that is true at each recursive call. So the right way to program a function is to start with the specification. And the right way to program a recursive function or a while loop is by starting with the invariant.